es un poco malo.
开始了，你好吗？
我很好，你好吗？
你今天很晒。
Oh, sí, sí, pero la tarde ya.
是，你在干嘛？
Okay. Oh, wait, sorry. Hey, guys, ROS developers, welcome back again to a new ROS Developers Live class. I'm sorry for the technical problems that we suffered. So let's see what happened today on the class, because while we were doing the latest test for the notebook, we found some errors and we tried to solve them. Let's hope that everything has been solved in the rush that we have been running. So anyway, let's go straight to the work. So what are we going to do today? Today, we are going to see how to test different reinforcement learning algorithms on the same robot on the same task. So imagine that you have that you have a task that you would like to solve on a robot, for example, like learning how to grasp something. Then on that thing, you would like to try different algorithms to see which one of those is the best for this problem. So we have a device system that is based on the OpenAI ROS package that is going to allow you to change those algorithms in a very easy way. So you can test this one, see what is the performance, and then take another one, see what is the performance, and then by doing this, compare all those algorithms and then select the one that is the best. That could be useful, for example, also for doing some kind of benchmarking, or also even a competition. So you want people that build the best algorithm for a robot solving that particular task. So that's another example. So let's see how to do this very easily and very quickly. So the first thing is that we are going to use the ROS Development Studio, as you already know. And what is the ROS Development Studio for the new people that came to the channel? It's a tool that we have created at our company that it's called the Construct. And it's a tool that allows you to program ROS robots on the web. So you can use your Linux machine, but also your Windows machine, your Mac machine, to program those robots and see in real time on the simulated robot the results of your programming. So we are going to use that for the free account. If you don't have an account, just go and create one right now. And what I'm going to do is I'm going to share with you a ROSjet. A ROSjet is a ROS project that contains simulations, ROS code, notebooks. So I'm going to share this within the ROS Development Studio so you can get up to speed into the class that we are going to do. So you don't have to build the simulations, you don't have to build much of the code. So you can follow and then use this for your later experiments after the class or for whatever you want. So let's go for that. Remember that we have a chat on the side of this transmission on the YouTube channel. So if you have any questions, if you have any doubt, I will be checking that periodically. Today I only have one screen, so it's going to be a little bit more difficult for me to change to the screen. So let me have a look if there is. I see here some comments of people don't see anything playing yet. I hope that you are seeing already. Moscow Online, Speedy Step, great. Raspberry Pi, great tool for developing ROS with Apple, Swift language, and iOS. Okay, so let's see. No, okay, looks like everything. It's okay. If you have any problem, tell me. Okay? So let's go. Let me show you my screen so you can see what I am doing for sharing this ROSjet. So you are going to see now my screen on the YouTube channel. And what I'm going to do is here, come to the ROS Development Studio. Sorry, I was testing. Here it is. So this is my application. And this is the ROS Development Studio. And here there is the ROSjet that I have prepared for this live class. And I'm going to share this with you by pressing this button, Share ROSjet, and then providing you with this link. Okay, so because this link is too long for the chat that we have there on YouTube. I'm going to use Google to make it shorter. So I'm going to put it here and shorten and copy this link. Okay, so I got it copied. And then what I'm going to do is to go to the chat here and paste the ROSjet link here on the chat. So what do you have to do if you are attending this live class? Just click on that link, and by clicking there, you will get a copy of my ROSjet that I have it here. Okay, so yeah, I hope that this is clear. Just click on the link, and then by clicking there, automatically you will have a copy of this ROSjet. And I'm going to wait for a minute or so, so everybody is on the same page. So everybody has understood how it works. It has clicked on the link, and then it has also got the copy of the project. So, and then in a few seconds, we are going to start opening it, okay? And start working with it, because we are going to use the content of that project in this class. Okay, so let me know if you have any problem. I don't see any problem on the chat. And I'm waiting here for you. So I hope that you are there. Okay, so looks like everybody is working and following. Great, this is great. Okay, yeah, so then let's go directly. So I'm going to open the ROSjet, press here on this button, open, and then it says open. So it says some descriptions, etc. And here we have, okay. Yeah, okay, so I have here a page not found. So let me check what is happening here. So I don't know what happened with that. But in any case, you should have received, you should have opened, you should have opened something like that for you. Let me know if that's not the case. So you should have reached this class here, this screen here that explains about the live class that we are going to do today. So let me know if it is not like that. The chat. And I see that Cheryl had a problem, but the people on the team is answering there for you. Okay, so let's continue then. Great. So let's go for the subject of today. Then what is this class? As I mentioned already, so this is the introduction, how to test different reinforcement learning algorithm. And we are going to use ROS and Gazebo. And what is important here to say is that those reinforcement learning algorithms, they are supposed to solve the same task on the same robot. In future classes, we are going to see how to maintain a reinforcement learning algorithm and test different robots on the same task. You will see that the OpenAI ROS package is quite nice for doing this because it's very modular in this sense. But anyway, today we are going to test different reinforcement learning algorithms, and so we are going to use the OpenAI ROS package that you can get the code here on this link that you have here. And as I mentioned, this live class is provided as a ROSjet. The ROSjet is the whole project that I share with you, and that you can share with your peers also, in case that you want. And in case that, so here there is more about ROSjet, how do it work, how to create, etc., in case that you want to build your own ones. And here you have a link that if you select this cell and then you press play, then you are going to see a link to this transmission. So later on, you can replay this video and continue and do the same notebook, the same class again, in case that you need it. So what are we going to do here? Which task, which robot are we going to use for this example? Well, we are going to use the carpole. You know what is the carpole? Let me show you here an image. A carpole, you know, is this kind of robot, very simple robot that can move to the left and to the right on this rail, and has a pole on top, and this pole has no control, so you cannot control the position. Then it's going to fall to one side or the other. Then the only control that we have is here on the car pole, so we have to move it to one side to the other in order to balance the pole that is there. So the robot has to learn to balance that pole. That's what we are going to do. That's what we want to do. And for that, so here you have more information about the car pole, of course, that you can check later. And what else? Yeah, so in this case, this is the algorithms and the car pole definition environment from the OpenAI directly. But as you know, OpenAI Gym, the list of algorithms and environments that OpenAI provides us in order to test reinforcement learning algorithms, it solves the problem on a 2D flat surface and without an accurate physics simulation. So I have included here a video that you press play here, select that, and you press play. So you're going to see what I mean by the 2D, and you can see that later with more detail, but basically it's a flat environment in 2 dimensions and with very limited physics. So it's quite simple environment for solving. In this class, we are going to solve that problem on a 3D gazebo simulation with full ROS controllers. So the reinforcement learning algorithm has to learn how those ROS controllers work, also in order to balance that. So it's a little bit more complicated. This is also is closer to reality. Remember that what we are doing here, you can apply later to any other robot. Okay, so this is just a basic idea for applying later to other more complex robots. And then in this ROS jet, we have included this simulation of the car pole. So let me show you. Let me first launch the simulation. So let's do it together. You do it with me. For that, you go here to the ROS Development Studio, to the simulations, and then here you can see a list of robots that are already simulated on this on the ROS Development Studio. But in this case, it's a simulation, a specific simulation that I have put inside this ROS jet. So we have to go to this option here, select launch file, and then on this menu you have to go to car pole description main launch. Select that one and then press launch. Then a new window should appear here with the gazebo simulation of the car pole. And in the meantime that is loading, let me show you where the code for that simulation is located in this ROS jet. Let me show you in the meantime. Just go to Tools and then select the IDE. The IDE is the tool that we are going to use in order to program and to develop our programs for ROS robots. So if you open a little bit more, you can see here, let me close it to make it simpler. And this data, so this data directory is just rubbish that I'm going to delete it. If you have that, then you can delete it. It's because of the quick experiments I was doing previously to the live class. You can delete it safely. So basically our system organizes the packages in those workspaces. And the most important ones are simulation workspace, notebook workspace, and casting workspace. The simulations that we want to include into this ROS jet must be included inside the simulation workspace. So if you open it and you go to the source, you will see that there is the car pole packages, ROS packages, gazebo packages for the car pole simulation. So here is where you can find our simulation, and you can use it at will. So here is the complete description with the plugins, with the controllers, everything is there. So you can get it and use it at your will. Great. So you can see that the simulation has loaded. And now, there it is. So now what do we have to do? Well, so, so let's see which one are the algorithms that we are going to test. So we are going to test 3 algorithms here today. Actually, we are going to test only 2, and the third one is going to be for you as a homework to follow the same process, okay? So those algorithms, we took them from the OpenAI Gym website. In that website, we can see those algorithms solving the 2D carpal system, carpal problem in 2D. So what we have done is to take those algorithms and modify them for being used in this simulation using the OpenAI ROS. And you're going to see how simple it is. Basically, we have to do 2 things in order to adapt those here. Let me clarify here because it needs to have here. Yeah. So we adapt them. So we download them and then we adapt them to the carpal 3D environment by doing those 2 things. First, we load the learning parameters from a YAM file instead of loading those from global variables. And this allows us to change the values very easy and also to use the gene computers afterwards, where we can launch multiple computers with the same simulation, different parameters, and see what are the results. We are not going to see this option today. But we are going to see how to separate the parameters into a YAM file and load them from the algorithm that we are going to test. And then we have to change the OpenAI environment from the 2D carpal provided by the OpenAI. That is the one that you have seen in this video here. Okay, this is the 2D carpal. It's still there. Let me pause it because it's 1 hour. So I don't want to keep it running there. So we are going to change from that environment, from that environment to the one provided by the OpenAI ROS package, which interfaces directly with ROS and Gazebo. So you don't have to do anything. The OpenAI ROS package already provides the interface and the environment for connecting reinforcement learning algorithms to that simulation using ROS. And you're going to see how simple it is. Okay, so let's create our package for training first. So for that, let's open a shell here in Tools and Shell. And let's go and create a package. Let me check first if there is any question there that I should answer. Let me check in a second here. Okay, so far so good. It looks like everybody is on the same point. Shout in case that you have any error or problem. Great. So let's continue. Then we are going to create a package. And as I mentioned before here, in the IDE, we have here the several workspaces for working. So on this one, we got simulation workspace. We have the simulation. Then we have notebooks workspace. That is where this notebook that I'm reading and you also can read. It's contained here, include the Jupyter notebooks and image files, etc. So it's contained there. And then any code that should run into the robot should go here in the Katkin workspace source. Okay, so you already have here the OpenAI ROS package that I have provided already for you with everything for the carpal and other robots. You can have a look afterwards at this or check our previous live classes where we talk about those. And here is where we are going to create our package for testing on this carpal. For that, what do we do? First, create a package. And let's create it everything with the same names, because otherwise I have prepared this project, and then otherwise it's not going to work because some names are hard-coded in the launch files, etc. You can play with them afterwards. This is in order to go fast. So let's go to the Catkin workspace source, cd Catkin workspace /source, and then create a package that is called with the command. It's called Catkin create package, and let's call this package carpal test _ tests, and then it depends on ROS pi. Done. Okay, then let's create it inside there a few directories. So let's go to the ROS cd carpal test, and then there let's do several directories. A directory that is called config, another one that is called scripts, and another one that is called launch. Okay, so we got it. Then what we are going to do first is to create the parameters file. So in a parameters file for the reinforcement learning, we have two types of parameters. There are some parameters for the reinforcement learning algorithm. Those are the parameters that tune the learning of the algorithm. So those are the most important ones. And then there are some parameters for the robot environment and task environment. Those are parameters that are used to tune the task and also the simulation. So in case that are needed. So in theory, when you are doing reinforcement learning, you have to have fixed the second set of parameters and just change the ones in the reinforcement learning algorithm, because you cannot trick the environment in order to achieve your goal. Your reinforcement learning algorithm should learn, should be modified, should be accommodated with the proper parameters to the given environment. So usually those parameters of the robot environment and task environment are created at the beginning when we are creating the whole setup environment without having tested any reinforcement learning algorithm. And there are some variables that need to be tuned in order for the simulation and the task and everything to work properly. That's why they are there. And here I have included some of the, a file for the parameters. So let's just directly create the file, the config file, and put the parameters there. So let's go to let's use the IDE now. Okay, so let me put it here. Here the notebook on the side, and the IDE. Let me arrange a little bit this to make use of the space that we have. And yes, so here in the carpal test, you see that the directory has been created. Let's go to the config, and then right-click and say new file. And here you have to create a new file that has to be called carpal _n1 try _params.yum. The name is written there on the notebook, but you should provide the same name, because afterwards in the launch file we are going to request this, and then otherwise it's not going to work. So let's open this. It's an empty file, and let's go to the notebook, select the whole content of the cell, and then copy and paste there on the file, on the config file. There you can see the learning parameters. It says QLearn, but it should say just the learning parameters, because it's not for QLearning. This, well, we can say QLearning because it's deep QLearning, but yeah, okay. So here you have the different parameters that you can tune for the learning. And I'm not going to describe them. You have already some comments there, and check our previous class, not the previous one, where I describe all those parameters. For the Taki Town, we use the same algorithm. And then we have the carpal 3D environment variables, that type of controller, the ranges, minimum ranges from which this task will be considered failed, velocities, number of observations, certain actions that can be done, etc. Some things that are related to the task. So let's save. Remember to save. Control S on this file, or go to File and then say Save. Remember to save. Otherwise, you will not have the file with the proper configuration. And so we have the config file that we have to create, and then the next thing that we have to do is to create the algorithm itself. So basically we have to download the N1 try algorithm from here, from this link here. So you can go and download it here in this page. You have here the whole algorithm. And then I have already done that and created here let me see, here, yeah, the modified version of it. So let's do one thing. Let's go here to our carpal test. Inside the scripts directory, do a right click and create a new file. And you can call this file as the name as it's on the notebook, that is called carpal 3D underscore N1 try underscore algorithm underscore with underscore ROS params.py. Yeah, we couldn't find another name, a longer name, so that's why we put that one. And that's it. So let's open this file, and you can select the code that is here in this cell, and select everything, and then copy and then paste here. So what are we doing here? Basically, we have copied. Remember to save, okay? Remember to save. Control S or File, Save. Then what do we have here in this file with this algorithm? Okay, so this is the learning algorithm. This is, and it's the one that we have here in the OpenAI page, but with some small modifications for working with our environment for Gazebo. But basically, the modifications are very, very simple, are very few. One of those is this one, that it's importing the training environment, because, of course, the training environment is not the 2D carpal environment provided by OpenAI, but instead is the 3D carpal environment, 3D provided by OpenAI ROS package. So that's what we do here. We need to import in order to get it. This is one thing. And then afterwards, if you go down here in the main, so we have changed the name of the environment for the one that we are providing. Okay, this is related to the creation of the task environment. This is the only thing that you have to do. And then the other thing that you have to do is to modify the algorithm to get the parameters from the ROS param server. And you can see that this is very simple. It's just reading, getting from the param server all the parameters that this algorithm requires. Okay, you can check those parameters on the original here. So it's those epsilon mean, epsilon decay, etc., etc. So you can see that instead of getting those kind of hard-coded, we are getting them from a parameter server of ROS. And who has loaded those params into the parameter server? Well, at runtime, we are loading this config file that we have created into the ROS param server, and then they are retrieved here in the code of the training algorithm. That's simple. It's that simple. So two things. First, here from OpenAI, import the environment, and then load the parameters from the param server. And I think that I'm not forgetting anything. Let me check it because I have written here below. Yeah. Yeah, so another thing, sorry, it's that I forgot to mention is the ROS Note init. So because this is a ROS Note, so we have to include this line here. That is the one that identifies this program as a ROS program. And because it's a ROS program, then it has access to the param server, and then it also can access the robot topics afterwards. But all that access of the robot it's hidden for you in this case, because you are using the Carpool 3D environment task that it's already provided for you by the OpenAI ROS program package. So the OpenAI ROS package contains several robots and tasks. You can have a look here at the inside the, where is it here? Yeah. You can have here some robot environments for very famous robots like Usarion's Rosbot, WAM, Parrot Drone, Sawyer, Shadow Robot, Summit from Robotnik, Turtlebot 1, 2, 3. Many of those are already prepared, so you don't have to care about connecting to those simulations. And those simulations are also provided here. Well, that's another issue for another day. So basically that's it. Then the only thing that we have to do now is to create a launch file. So let me come here, AI ROS, and create a launch file here that it's right click, new file. Let's go start underscore trading underscore and one try dot launch. Okay, and if you open that file, then you can copy what is here on the notebook and paste it there. And always remember to save. Remember to save, because later people is asking me, hey, what is happening here? I cannot get that. It's not working, probably because you didn't save. So 1 minute for everyone to follow and see if you have any trouble. Let me know on the chat, please. I'm having some water. Okay, it looks like everyone is on the page, is following. RJ is saying all good. Very good, RJ. Done is that, so far so good. Very good. Great. This is great. And everyone, nobody else is shouting, so I think it's great. So then now it's a moment that we have been waiting for, is to launch the algorithm. So let's go straight, launch. We'll see the notebook later, but we want to see this robot moving. So let's go. Let me put it here on the foreground, the simulation. Go to Tools, Shell, and then do a ROS launch, Carpool underscore tests. Then your start training. And then let's cross fingers. Oh, damn it. Yeah. Okay, let's go. Let's see what's happening here. An error. First error is that is can locate. Yeah, that's execution permissions. So let's go. We have to change the permission of this file, of the Python file. Go ROS-cd, carpool tests source, and then here. Sorry, it's not source. It's a script. So scripts. Here you will have that. So you do a chmod space +x and then the name of the file that is called the Carpool 3D. Then you got it. Okay, so now it is time. We can relaunch now again. So let's relaunch and see what happens. It starts or not. Okay, yay, there it goes. So now it is training. As you can see, the robot is moving from one side, and then it's restarting again from the beginning. So it's because the pole is full too much to one side, then the system restarts. Then at any point in place, you can go to Tools and open the OpenAI reward chart, and you can see how the reward is being executed. So it's being obtained. So there is a bug now in the system and only plots since the first time that you open it. So yeah, we missed the first 36. Yeah, it's something that we'll solve in the next week, so don't worry, nothing important. But as you can see, it's trying to do it, and then if you leave it for several generations, you will see that the robot is able to balance the pole. And yeah, well, it will have to take some time. So you tested and you told me about that. And then, here you have a few more details about this adaptation of the N1 try algorithm to solve this task. So what have we done? Modifying from here to be able to work in this ROS environment. Hey, look at that, it's almost there. Yeah, it's getting better. It's getting better. Look at that. Look at that. Yes, almost get it. Okay, so you have some more details, okay? But basically it's what I mentioned. It's just as simple as that, the adaptation, okay? But adapting the code from OpenAI Gym to our Gazebo ROS environment was not the point of this. Even if it's a good point, it's a very good point and very interesting one. The interesting part is that, okay, now we are testing this and trying, so we want to generate this reward chart for this one, and then we want to compare with another different algorithm or a bunch of others algorithms. How do we do that? Okay, so the thing is that it is as simple as changing your configuration file and your Python training file. And on that other algorithm, you only have to do is the same thing that we have done, is to import the task environment and get the parameters here from the ROS param server. And I think that in this case, yeah, are here. Yeah, in this case are here. So it's basically the same thing, and we are going to test that with another different algorithm right now. It's called the MValue Novick algorithm. And it's the second one that I have put it here in the list of algorithms here, this one. Okay, so if you press there, you will go to this algorithm that is included here. And instead of getting the parameters from here, we are getting those from the YAM files, so you can play with them. Great, it's almost there, huh? Yeah. Let me know if yours is also almost there. Just a few generations, and also using, so at present we are using a 2 CPU core here. So no GPUs, all of us. So it's quite good results. Okay, then here there is a question on the chat that is from RJ that says, can you post the code to make it an exe? What does it mean, an exe? I don't understand, RJ. An exe, I think that you don't mean the executables from Windows. I hope that you don't mean that, because never mind. Okay. Okay, RJ. I got it. Yeah, great. Okay. No problem. No problem. So let's go. Let's continue and let's modify that. So how do we do that? Very simple. We create another configuration file for the second algorithm, the MValue Novick algorithm. So let's create another one. Let's go here to the, to the config directory, right click, new file. Then let's call it carpal underscore MValue Novick underscore params dot yum, and then you open it and copy the content here. So in order to understand the parameters here for the algorithm, you need to go to the original algorithm. So that is something that I suppose that you already know. So it's when you want to try different algorithms, it's because you know those algorithms and you want to try them, so you know which ones are the parameters. We have already analyzed that for you and provide them here for you. So they are, but it's not the point of this class to discuss about those parameters. Just go to the algorithm, figure out which ones are the parameters for that, and include them here in the first part of the yum. That is the one that is indicating the parameters for the reinforcement learning algorithm. Then there are the parameters for the task environment. Those are fixed if you have a robot that is on the same task and the same robot, then those are fixed. So for all the algorithms that you're going to train. So the same values are here for this algorithm than for the N1 try. You can check it later. Great, so we have that config, and now we have just to get the algorithm itself. So let's get it here. It is here in this cell. Let's first create here on the scripts a second file for learning reinforcement learning file. So right click, new file, and then call it as it is indicated in the notebook. It's called carpal BD underscore MValue Novick underscore algorithm underscore with underscore ROS params .py. I would say in the name of all the reinforcement learning pioneers.py also. We could have also added that, but I don't know why we didn't add that. So in any case, anyway, there is the name. So let's open it and go to the cell, Control A to select everything, Control C to copy, and come here, and then Control V to create the code, and then save. Okay, once you save, you can see the same things as we have done to adapt this algorithm as in the previous one. It's the import here of the task that is exactly the same because it's the same task, same environment. And then here at some point, we have the get params as well as the init ROS. It has to be here. Oh, it's not there. ROS. Okay, it's here. Okay, the organization is a little bit different, but yeah, but that's something that you have to figure out because it depends on the algorithm. So we have organized different way because the algorithms are different, also organized. Yeah, but the concept is exactly the same. Initialize the node, import the task, and then provide the parameters as well as the name of the environment that you have to generate by OpenAI. Remember, in this case, it's the carpal stay up. In the original one, it's the carpal environment here. That is the carpal environment. Let me see. Where is it? Here, carpal. That means the 2D environment. Okay, so we have changed that name there. Also for our environment. This environment, I repeat, this environment is the carpal 3D in Gazebo. And this is provided already by the OpenAI ROS package. So that is why you don't have to build this environment. If you want to train for different robots in different situations, then you will have to build your own task environment. And in the OpenAI ROS package that is here, we provide here some templates so that you can use here. I don't remember where was it. It's to be here. It's a template for creating your, here it is, templates. Yes, for creating your own environment for a robot or for a task, for a training environment. Yeah. So that's the case that you want to apply this method to another robot in another task. For example, remember that we're providing for other robots and we are creating more environments for more robots and more tasks. So our goal is to include in the OpenAI ROS package all the ROS robots that exist in the world. So you will not have to create that unless you have a very special robot. But that's the thing for the future. Okay, so we have here the algorithm modified. Let me save the config. I didn't save. And now we only remain to create a new launch file, as is indicated here, for launching this second algorithm. So let's go to the launch directory, right-click, new file, and here create a new file that is called start training underscore MValue Novick.launch. Then if you open it, and you can copy the code that is here on this cell. And we'll be able to launch it. Now, remember to save, remember, we are ready to test it. So that's the reward chart that we have obtained up so far with 200 generations. And as you can see, the robot is learning, it's getting better, it's getting better. It's getting better. Great. So now it's time that we close this. You can take, of course, a picture. You can take something because we are going to erase this. So you can close this and then go to the shell that we already opened with the launcher. It's here, and do a Ctrl+C to stop it. And the robot went away. No worry, it's going to recover by itself. Now it's time to launch the second one. So let's try to see. So ROS launch, carpool, tests. Then we have a start training, MValue Novick. That's it. Oops, I pressed too many tabs. That's it. So let's launch it. And again, we have the same problem. So we have to change the execution permissions for that new script. That it's called carpool the MValue Novick. Yeah. Okay, done. Let's launch it now again. Let's see. Let's see if this is going to work. And there it goes. There it goes, and there we have the system running. Great, with the second parent algorithm. So you can see how easy it is. It has been, okay, it has some work. Yeah, I know, but I mean, we have been doing this in less than an hour. So that's super cool. And let me see if you are reaching that point, if it's working for you. In the meantime, let me put it here. Let me check the questions. And it's Amel Derwich that says, hi everyone, I know it's random, but I'm searching for projects about 3 arms Delta robot on ROS. Can someone help me, please? Okay. For projects, what do you mean by projects, Amel? Do you mean that it's about simulations, or you are asking for research entities that have projects that accept interns? What do you mean by that? Please clarify. And I don't see any questions here, so I suppose that everybody is learning, so is making the robot learn. Let's have a look at the reward chart. Let's plot it. And then in the meantime that the system is learning, let me go here to the next step of the notebook. is, well, we have done it. And then I will leave the repaste SOTOC algorithm to do the same thing. So you know how to do it. You have seen all the steps. So what I suggest, if you would like to learn really a lot about OpenAI reinforcement learning algorithms, how to manage this with ROS, etc., go and do this exercise by yourself. And in case that you have trouble, you have problems, just let me know, and I will be happy to answer those questions for you. And basically, that's it for today. So I'm going to answer some questions for you. So I'm going to wait here for some more minutes in case that you have more questions. But before you get out, please remember to give us a like and hit the thumbs up button that is here, because that's helping us in case that you like it, our system. And let me recommend you that you subscribe to our YouTube channels, because we are publishing a new video every week showing you interesting things about ROS and Gazebo and OpenAI, self-driving cars, etc. Just in case that you want to learn more and go deeper in your ROS learning, let me tell you that we have an online academy. It's called the Robotics Ignite Academy. And there we teach you many things, like the basics of ROS, for example, in case that you don't know, in C++ or Python, or things super interesting like more in-depth algorithms of OpenAI, how to use ROS for self-driving cars, how to do ROS with manipulators, industrial robots, drones, etc. Have a look at there. It has a small cost for that, but I have included here a coupon with a percentage of discount, 7% discount, that is valid until tomorrow. So you can try with a given discount. And then the last thing that I would like to recommend you is the ROS Developers podcast. That's a podcast that we are publishing every week, where we interview some very interesting people from the world of ROS, and they tell us how they program the robots with ROS. What are their projects with ROS? So you can get a lot of insights from experts of ROS, how to do your things. You can download some of the codes that they are providing or talking about. You can get here some examples that you can visit later and see if that's interesting for you. And that is all from my side now. So let me go back to the questions and let me see if there is any question. Okay, so I see that there are some questions here. And let me just stop this sharing for, yeah. Okay, guys, so let me see. Yeah, today we don't have a very good light here, but my colleague here is providing me better light. Great, thank you. Thank you very much. Appreciate it. And then here's some questions. Then RJ says, can you post, no, sorry, that's already done. Can you explain me the difference between OpenAI Gym and OpenAI ROS? Okay, that's a very good question, RJ. So OpenAI Gym, it's an environment that OpenAI, the organization, OpenAI, it's an organization, you probably know. So that organization has created something that is called the gym. The gym, it's a place where you can train, you can compare different reinforcement learning algorithms against some tasks that are already there, created by the OpenAI organization. There is a chance that you can provide some other tasks there, but they are not based on ROS, they are not based on Gazebo, they are based on their own environment system. That is a lot more limited than the one that ROS and Gazebo is less real than the one that ROS and Gazebo is providing. So what we have done is to create this package that is open source, that is on the ROS wiki, so you can go there and download and do whatever you want. That is called the OpenAI ROS. So what does this package is to allow you to interface the OpenAI algorithms that they have created, or people is creating for the OpenAI environment. So you can interface those algorithms with ROS robots. So in an easy way. So you don't have to care about all the ROS topics, all the how to send the commands to the robot from the reinforcement learning algorithm. So we are hiding all that for you, so you can concentrate on reinforcement learning itself. So basically, that's the difference. Then says, is OpenAI ROS simply a package that works on top of GIM? Yeah, I would say that also. Yeah, I would say that, because we are using the GIM structure for creating the reinforcement learning loop. So that is already provided by OpenAI, GIM. That is the whole getting the instance of the algorithm, getting an action, applying this action into the environment, then getting an observation, using this observation to generate a reward and provide this reward and the observation to the algorithm again. So that loop is already done by OpenAI, and we have integrated with OpenAI ROS, we have integrated that into ROS and Gazebo. Okay, Cheryl is saying, are there any reinforcement learning examples on OpenAI with other robots? Okay, in our OpenAI ROS package, there are several. So you can go to the OpenAI ROS package and you will see some, for example, with a water vehicle. There is another one with a turtlebot, and there are another one with a cube that is a rotating cube, so you have to make the cube rotating. There is another one with a jumping robot like this. Super interesting, that one. And many others, and we are creating more. Okay, so RJ says, yeah, look in their playlist. Okay, yeah, so he's answering. Yeah, Danis does say, is it possible to open tabs in the ROS.ds shell instead of open several windows? Not at present, but it's going to be. So just give us some time more to do that, and it's going to be. Yeah, because I also agree with you with tabs are super cool. And also even more to have like Terminator, different types of shells on the same shell, like Terminator, for example. That's something that we are going to work on that. Okay, RJ says, got it, thank you. And let me see, any other questions, guys? So I'm here for you. A few minutes more. It's been already 57 minutes. I'm sorry for the delay, but I think that we finally achieved to get it working, everything, and that you got a good overview of how to change reinforcement learning algorithms in a robot task that is based on OpenAI ROS. Okay, so if there is no more questions, then I'm going to close it here. Remember that we are going to have another class, live class, next Tuesday. So stay tuned. It's going to be about also about OpenAI and how to test different parameters for the same reinforcement learning algorithm. Okay, so there is another question here by Keith that says, have you guys switched it over to ROS 2? So yeah, present you can work on ROS 2 on the ROS Development Studio. So you can go and do your test. It's based on a Docker machine, and we have published some videos about how to do that. So if you look into our channel for ROS 2, into our YouTube channel, you are going to see a couple of videos that show you how to start with ROS 2 in the ROS Development Studio. And it says, I see Microsoft has started supporting ROS, which is plus. Yeah, that's right. 2 weeks ago at the ROSCon, Microsoft presented ROS for Windows. That's super cool project and very nice. That's very good. Okay, guys, so that's all for today. Thank you very much for attending. It's been my pleasure. Sorry for the delay. You are amazing people because you have been there waiting for the class. And I really appreciate that. Really, really. Thank you very much, guys. So thank you and see you next Tuesday, okay? Bye, guys.